I'm Becky Hall. I'm the Executive Director here at the Nevada Science Center.
I'm Dr. Josh Bonde, and I'm the Director of Research.
So we're here in downtown Henderson, Nevada, so Southern Nevada, at our research lab where we bring our fossils that we discover and collect to research. So me and Josh are both paleontologists. We study fossils from around the state of Nevada, and today we are celebrating, drumroll, National Fossil Day. So National Fossil Day was created by the National Park Service. It's a day to recognize our fossil resources across the country. And here I have a little poster from the National State Park. So they have fossils in a whole bunch of different parks around the country. It says at least 243 National Park Service areas have fossils. So it is an important resource to preserve in our state parks and on our public lands. So today we're going to be talking about some of our research projects, how we collect fossils, how we find fossils, and then we'll wrap it up with some Q&A. So we'll get started with some show and tell.
Sure. So what is a fossil? First off, talking about National Fossil Day. So fossils are the remains of any previously existing life. And so those could be stereotypical, like you think about bones. So it could be a dinosaur bone, it could be a track in the mud, or it could be a wood impression or petrified wood, or shells from corals or clam-like animals. So anything, let's say, artifact or a remain of a previously existing living organism is technically a fossil.
Right, so we're paleontologists, so we study the life that's preserved in the rock record, and sometimes it gets confused with an archaeologist. So why don't you tell me what an archaeologist is?
So paleontology, we study, as I just mentioned, previously existing life. Archaeologists study how people have interacted with their environment through time. So the difference between archaeology and paleontology, even though there is some overlap, is that paleontology doesn't typically focus on humans, whereas archaeology has a very strong human focus.
So we have a lot more older things here.
Yeah, we have fossils. Most of our fossils are before people even were on the planet.
All right, so let's start our show and tell. How about that?
All right, so let's take a look at some fossils from around the state and through geologic time.
All right, I'm gonna switch you around again. Switch. Hang on, flip you around. There you go.
All right, so the oldest fossils that are from the state of Nevada are about 900 to 700 million years old. And what these are is they're just simple little layers in limestone called stromatolites. And stromatolites are just fossilized pond scum. So if you ever slipped on a slippery rock, or you've seen a slippery rock on the edge of a lake or on the edge of a river, those types of organisms have been around for hundreds of millions of years, almost a billion years. And those are the oldest fossils we have in our state. The oldest animal fossils we have are about 530 million years old and come from trilobites. So this is a trilobite. It's kind of a showy one. This one's from Esmeralda County, from the Polita Formation. This is the head. These are the eyes. And even though this thing is over 500 million years old, if you look really close, you can even see where its blood vessels were on its head. So really well preserved. Trilobites make really cool fossils, even though in real life they were probably disgusting little animals. So they scurried about on the bottom of the ocean floor through the mud, eating all the stuff that settled through the bottom of the oceans. So if you find these types of fossils on public lands, they are collectible. So I guess I should mention, where can you collect fossils? So on federal lands, you cannot collect any bones or remains of vertebrate animals. So vertebrate animals are those that have a backbone. So you can't collect dinosaurs, you can't collect saber-toothed cats or anything like that without a research permit. And all the fossils we're going to show you in our lab were collected either under permit from the Bureau of Land Management or from the Nevada Division of State Parks. If you're on national park land, state park land, or federal lands administered by the Bureau of Land Management or the Forest Service that have special designations, you cannot collect fossils. But if you're on Bureau of Land Management lands and Forest Service lands without special designation, you can collect invertebrate fossils, trilobites, or petrified wood as part of your own private collection. What the caveat is that you can't sell or trade them for other stuff. So it's only for your own personal use. So that's the legal part of collecting fossils. Some other fun stuff. This little one, it's tiny, but I like it because it's cute. This is a little ammonite. It's about 320 million years old from central Nevada. So this little whirled up thing would have looked kind of like this. So this is our toy with the whirled up shell and little squid things sticking out of the front. This was a favorite food of, oh, it's behind us here, my teaching props. Oh, there we go. Our state fossil, the Dinosaurs popularis. So this is a plushie that you can get at some of our Nevada state parks. So this is Nevada's state fossil. The Dinosaurs, which kind of look like a dolphin or a whale, were actually marine reptiles that lived during the age of dinosaurs. Even though they weren't a dinosaur, they're a marine reptile. These things get up to 75 feet long. In places like Canada, the biggest ones in Nevada get about 50 feet long. If you want to see a Dinosaur, you can go out to Berlin Ichthyosaur State Park, where there's still some in the ground. So one of our great state parks. Some other fun fossils. I just showed you petrified wood. So this is a piece of petrified wood, which is about 230 million years old. It's from the same time period as Petrified Forest National Park, from a period of time when these great big cypress-like trees were growing along swampy environments here in southern Nevada. So fossils tell us not only who was living there, but also what the environment was like. This is a piece of stump from a tree fern. This one's about 100 million years old, but was growing on the riverbank here in southern Nevada about 100 million years ago, and probably was food for dinosaurs that were living in the area at the same time. I really like this one. It's much younger than the others I showed you. So this one's about 12 million years old. You can see the petrified wood in here. But what this specimen also has, can you see it there all right? All these individual little blobs are seeds. And so this was somebody's seed cache. So either a squirrel or a crazy bird stuffed all these seeds in the hollow of a trunk 12 million years ago, and then the tree fell over, got buried, and turned into a fossil before they could come back and eat their seeds. We have lots of Miocene age rocks, again, about rocks that are about 12 million years old across Nevada. So a lot of our fossils are about that age. So this is the elbow of a camel, also about 12 million years old from your Fort Churchill State Park. These are also about 12 million years old. These are little stickleback right there and right there. So these are from halfway between Fallon and Reno, Nevada, so up in western Nevada. And if you look really close here, they're actually preserved in other fossils. So these little layers are layers of algae fossils. So when lakes turn over during late summer and all the algae blooms and then settles to the bottom of the lake, all those shells make these little chalky layers. So every layer there is a summer, millions of years ago. So I will hand the reins over to Becky so she can continue the Q&A, or not Q&A, the show and tell.
All right, so we'll go on to the bigger animals that were preserved here in Nevada, and that's the dinosaurs. So we have two areas in which we collect or find dinosaurs and collect them and bring them back to the lab so we can research them. One being the Valley of Fire State Park. So that's about 45 minutes north of Las Vegas Strip, and then in central Nevada, you're just outside Eureka, Nevada, which is a small little historic mining town about 5 hours north of Las Vegas. So we'll talk about first some of the dinosaurs that come out of the Valley of Fire State Park. So one that I've been working on for a while now is a hadrosaur, so a duck-billed dinosaur, 100 million years ago. So here's one of the backbones to it, one of the vertebrae. So they would have had vertebrae from the base of their skulls all the way to the tips of their tails. So we find actually quite a bit of vertebrae. So I have a whole bunch of pieces of them. They're more robust, so they're heavier and chunkier, so they're preserved a little bit more easier than the more delicate bones. So why have I been working on this bones probably for past like 5 years is because I have to prepare them. So the purpose of our lab not only is to research them, but we have to prepare the fossils when they come to the lab. They don't come up all clean and pretty, and sometimes we have to piece them together. They come, and this one specifically came in a really, really hard sandstone that I have to basically chisel the bone out of the rock. So if you look here, good. You have the rock, so this little like ashy color here. You can see some scratch marks in it. So that's from my tool that I use to remove the sandstone grain by grain. And then in here, you can see a little bit darker, little outline. That's the bone in there. So I've been working on this for the past 5 years, slowly chiseling away the bone that is inside. So hadrosaurs were the cows of the Cretaceous, so big plant-eating dinosaurs that roamed the riverbanks that once flowed through southern Nevada here. So other dinosaur bones that we get from Eureka. There's a couple on this main table here. So these are our newest discoveries, and we still don't know a lot about them. So there's two different sites up in our dinosaur land. And as you can tell, we just kind of have a couple chunks. So most of it's still in the ground and we still have to go excavate it, but we had to bring back a couple to the lab just to preserve it so they wouldn't get more damage in the weather elements. So you can tell this bone is very chunky and large. So this is just a little piece of the bone that came off the dinosaur. So how do we know it's bone? If you look at the inside here is the texture. So as paleontologists, when we're looking for fossils, we're looking for patterns or textures in bones. So you can tell here, it's more grainy. It looks like the inside of a bone. So this would have been the inside of the dinosaur bone. So not just the grainy texture of the bone marrow, but we also have textures in the petrified wood. Can you have me a piece of that petrified wood?
There you are.
Thanks. So here again, we are looking at textures, and you can see the linear or parallel lines that run down just like it would today. Sometimes you can even see in the cross section the rings from like a tree ring. So that's what we're looking for when we're looking for fossils when we're going out hiking, and that's what you can look for too. So patterns and textures and rocks.
What are some of the tools that you use?
Sure. So here in the lab, we have a kind of different set of tools. So we have tools in the lab, tools in our pack when we're looking for fossils, and then tools we use to excavate. So I'll show you a couple of these smaller tools. Come closer. So we also have big dinosaur fossils. We also have little tiny microfossils. So things that, let me just stand up. So things that we have are like paintbrushes. So there's not a special store we can go get paleontology tools. We kind of are resourceful. So paintbrushes are used to brush up very delicate fossils or sand or sediment. I think you guys all know what these are, right? You go to the dentist, he might use this, and then you're sent home with one of these. So no, we're not dentists here at the lab. This cleans your teeth, which are bone, and can also clean off the fossils. So this dental pick is very good to get really delicate in there and remove some of the sediment. And toothbrush, just like a paintbrush, it's actually a little bit, gives us a little bit more detail with the toothbrush. We got tweezers, picking at little things. I'll open the toolbox. You still see the toolbox?
Mm-hmm.
So in here, we also have a little bit of odd items. So if you have a younger brother, sister, or cousin, you might have seen one of these. So they're used to suck out boogers from little ones, but they can also blow dirt away very carefully from fragile bones. So a lot more paintbrushes, so different size paintbrushes for what we're doing. Chisels for a little bit harder things to get at. More tweezers and glue. So try not to, so we have to, bones don't always come in one piece. So we have to use special glue to put them together to preserve them. Things that you might have or must have in the field, all geologists should have, or paleontologists, is a rock hammer. So banging on rocks, splitting open rocks. So that's an important one. Here's a good tool. So going back to the dinosaur that I was removing the sandstone from. So I don't have this tool on right now. So something like this, right? So you can see the brown area of the bone, and the outside again is the sandstone. So my tool is used, it's not on because it's kind of loud when it's on, but it sends air, compressed air through the tube, which vibrates the end. It's called an air scribe. And that vibration is used to remove the sandstone. So those scratches in the sandstone is from this tool. So that's why it takes a long time, because it's literally grain by grain, removing the sandstone away from the bone. So that's an important tool too, here in the lab. And then our most recent dinosaur, if you guys have seen it or heard about it, is the first named dinosaur from the state of Nevada. And I'll send that back to Josh to talk about our Nevada-Dromia schmidti.
So the piece of artwork here is done by Julius Chinnery. So he's a really great paleo artist. So if you want to go check out his website, he has all sorts of really awesome artwork that is for sale. This is a piece he did on a related dinosaur to our Nevada-Dromius. So Nevada-Dromius means Nevada runner, and then Schmidti is in honor of Dr. Jim Schmidt, who is a longtime professor at Montana State University, and is the one that told me and our collaborators to go look in Valley Fire State Park for some of these rocks to look for some fossils, and sure enough, we found some dinosaurs. So let's take a look at what we got. Now keep in mind that these are not all the bones that we have with this animal. These are just the most complete ones. So what made this a new species or something new is looking at the thigh bones here. So you can tell this is not a large dinosaur. This is the thigh bone and it fits into my hand. Thanksgiving's coming up. So if you're at Thanksgiving dinner and you take a look at the thigh bone on your turkey, this thing would have been about the same size as the turkey thigh bone. So these animals were probably a little bit bigger, a little bit stockier than a turkey, but the thigh bone's about the same size. So what makes this an interesting new animal is this weird little thing on the thigh bone. So this would have been a muscle attachment for the tail muscles and probably some ligaments from the thigh muscles. So you're looking at the right, so it would have been like up here on the hip. Some other cool bones from this animal. We have some back bones. We have some toe bones. And so this is these special adaptations on this thigh bone make this animal probably a pretty strong runner. And as the name implies, Nevada runner. This thing was probably on the menu for lots of other types of dinosaurs. Probably spent a good chunk of its life running. And so that's where this group of animals typically gets the root of their name from. So I think with that, we can open it up for any National Fossil Day questions about Nevada paleontology or the Science Center.
Absolutely. And I got some already messaged in the chat and I had some emailed to me earlier. So those of you who are here with us, feel free to message any questions you might have for Josh or Becky in the chat. Some of the students wanted to know, are you guys able to tell approximately how fast, and now someone just asked, how do we pronounce Nevada-Dromius schmidti? Did I do it?
You did it, Ralph.
I just answered a question. All right, that's how you pronounce it, Nevada-Dromius schmidti. So is there a way that you guys are able to gauge or just kind of approximate how fast it would have been?
We haven't done those calculations yet, but there is a way to do that. So all animals that walk on two legs, there's a couple of equations you can use based on the length of the thigh bone, the stride length. You can eventually calculate that out. We need a little bit more of this thing in order to get the right measurement. So we're not quite sure yet. I would say a safe guess was this thing could probably run at least 30 miles an hour.
Right, and that also goes with determining how large an animal is. So sometimes we don't actually have the bones. I meant to go show those. I should have read them. Sometimes we don't have the bones, but we have the footprints. So the footprints can actually tell us a lot about the dinosaur too. Unfortunately, there's not too many circumstances where you get the footprint and the bones at the same time, but they both tell us a little bit more. So from the footprints, we can get a more accurate size of the dinosaur or animal running, and then definitely the speed is a lot easier to calculate.
Absolutely. And speaking of size, one of the students earlier, they wanted to know, what is the biggest fossil that you guys have ever found?
I think it's still on the ground.
Yeah.
So our two excavation sites in outside of Eureka, Nevada, where we have those big chunks of bone coming out. These were only little pieces of the bone, like these were the little pieces that fell off the bone. So we have the site probably opened up about 6 feet and it doesn't stop. So these are two more recently found dinosaurs, and we just, with the pandemic and everything else, we just haven't been able to go excavate those yet. So that's going to be a soon to come story.
Stay tuned.
Absolutely. We have a question from Miss Lucero's class that's right here in Nevada, and they wanted to know, how does the strength of the Nevada-Dromia schmidti compare to that of a Tyrannosaurus rex?
How do the
Strength, how strong is it?
strength? A Tyrannosaur, it would have been much stronger. You think of the little dinky arms on the front of a Tyrannosaur. If you were to embed those arms in the body mass of that animal, it couldn't even interlock its two little stubby fingers. But doing the people who study biomechanics, which is how animals and bones move and things like that, have determined that a Tyrannosaur could bicep curl 400 pounds. So Tyrannosaurs are much stronger than these things, but they could probably run away from them.
That is insane that you guys have that much statistics. I had no idea. I learned something new every day from you guys. So some of the students wanted to know, what is your favorite or most important tool that you have to use out in the field?
So besides your pack, so your pack is what your backpack, so you carry all your items in and your water bottles and bladders in, would have to be the rock hammer. So like I said earlier, every geologist, paleontologist should have a rock hammer, not just to be destructive, but it's a tool, can help you dig, it can help you, sometimes you have to break open rocks to see what kind of rocks they are. It's a pretty important tool.
And sometimes doing extreme paleontology, for lack of a better term, sometimes you have to use your rock hammer just to hold on to a cliffside.
Survival.
That sounds terrifying. So it's kind of on that same trajectory. One of the students wants to know, what is the process of digging a dinosaur bone out of the dirt? Because Becky had showed us that one that you've been doing for 5 years. Are there some that are easier than others?
Yeah, I'll start with this one. So the fossils that I was working on, that really hard sandstone, is not your typical that you see maybe, or you think about when you think about excavating. So excavating, you're digging around a fossil and then you're putting that white plaster jacket on and then bringing it back to the lab. We do that too. And that's going to be the dinosaurs that we're excavating in Eureka. Those will need, it's a softer sediment, so you can move around the bone with a shovel. So you basically dig a hole around the fossils to kind of protect them, and then you have to jacket everything. And they're really big, heavy jackets, and then you bring them to the lab where you can clean them up and clean the dirt away from them. It just really depends on the type of rock. So a lot of the ichthyosaur fossils here in Nevada are still in the ground because they're in a very hard limestone. So to chisel that out of limestone would be very difficult. So yeah, it really depends on the type of rock that the dinosaur is sitting in. Is it soft? Is it hard? And that determines a lot how you excavate it.
And the plaster jacket's a technique that hasn't changed in 250 years of doing paleontology. So it's just like a cast that a doctor put on your broken arm or your broken ankle. You soak burlap in plaster of Paris and you apply it, and then it hardens up.
Absolutely. And one of the students, they wanted to know if you've ever found a velociraptor. I know we were just in Utah last week, but have you guys ever found one?
So velociraptors come from Mongolia. And so we've never found a velociraptor in Nevada. But that's not to say that will never happen. The closest thing that we have from Nevada is we have a couple teeth and a thigh bone and a shin bone from an animal the same size as Deinonychus, which is like a cousin of Velociraptor. So we did have raptors here.
Now, were those aggressive, do they think?
Those were actually the very, Deinonychus was the species that was used by famous paleontologist John Ostrom to resurrect the hypothesis that birds are descended from dinosaurs. And so, and probably actually hunted in groups.
That's the thing of nightmares. I don't know why they're scary. So before we let you go, first of all, it's National Fossil Day. Happy National Fossil Day. What kind of advice could you give to any future paleontologists we might have on this call, if each of you guys could give some advice?
So go out and explore. So get outside, look for those patterns in rocks, get to know your surroundings, get comfortable just exploring and being outside. And then, engage your curiosity, read books, and go to museums and try to learn as much as you can.
Yeah, I would reiterate that. Just read, read, read. Find mentors. If you're really excited about it and you're in middle school or high school, volunteer, get experience. The more you read, the more you learn, the more you can figure out whether or not this is your calling or not.
Yep, start your own rock collection. Doesn't have to start with fossils. Go out and learn, you know, start your own rock collection and go from there. I think we all have rock collections we start.